Okay, here's our topic, this equation. Here's our objective. If I know K, what it means is what's this going to be, both numerically and estimation. And here's an example of what this means. Like I know this formula area is this, right? There it is again. How do I solve it for any variable? All right. Also, if I know area to be a certain value, like really big number, what does that mean about the length and the width? That there's two scenarios in general. They're both pretty big in general. Or one's really, really big, a lot bigger than my area. And that would allow my area to be big. All right, now, there's the correlation, and I feel like I might have spelt that wrong, uh, between these two values. I want you to have this number line down. I think it is helpful. This is for K, this number line here, and as K is less than 1, what is my delta G going to be? Well, my delta G is going to be positive. My K is greater than 1, my delta G is going to be negative. All right. And I like this because it's a nice visual representation of how the numbers like match up for these two different values. Now, here is the formula that links them. This formula is on your reference sheet, so you have it. Here it is. It's right down in here. Note it, but it's only written one way. All right. Now I'm going to go for a bunch of problems. Here's a chemical reaction. I know the delta G value. What's my K value going to be? All right. And in this case, we're going to solve it. So I'm going to use this formula. And then I'm going to plug my numbers in. Keep in mind your delta G, you got to put into joules. It's in kilojoules because the ideal gas constant is in joules, not kilojoules. So that's what you got to do. All right. Then I'm going to multiply those. I get this number. I divide. I get that. And then I take the exponent of that, e to that exponent, and I get this. All right. Which is what we expected based upon the correlation number lines before. All right. Now the AP is really good at asking questions that like connect two things and having you like apply it. Here we're applying my delta G to concentrations of these things at equilibrium. I know it doesn't say at equilibrium in the question, but that's what it's implying. Now we have this formula that we used in the last slide, but we're not going to use that. We're going to remember this correlation, these number lines correlation, and that I know that my delta G is down here is positive, so my K is going to be less than 1. And I know K is concentrations of products over reactants, and the way that I get a number less than 1 is I've got more reactants than products, so I'm going to have more of this than that. All right, I don't even need to use this formula at all. All right. Now, what about this problem? My reaction proceeds to completion. What does that mean about K and delta G? If it's completion, all my reactants are turning to products. Therefore, I am going to have a really big K and a really, really negative delta G. All right. What about this problem where I want to know, I'm given this and I want to know my Q in terms of K and which reaction, forward or reverse, all right? Remember that Q and K have the same formula, right? The reaction quotient and the equilibrium constant. K is just a specific value, what the reaction tends to after a given time. And remember, I had no products, so I've got all my reactants in there and none. Therefore, my Q is going to be really, really small. Small number divided by a big number, I get an even smaller number. And I know, well, my delta G is a negative and big. I'm going to have a lot of products because of the where am I on this on my visual? I'm over here. Therefore, my K is going to be really big. All right. So therefore, my Q is going to be a lot smaller than my K value. My reaction quotient is going to be very small. All right. And the reaction would favor the forward reaction. and almost like was the only one that's going to happen at the start. All right. Now here's one last thing. Nicotine, it's pH of 11. What's its Kb and what's its delta G? Remember, if it's not strong, it's weak for both acids and base. So this is not a strong acid because it's not a hydroxide with group 1 or group 2 metal. Weak, low, small Kb, all right, large positive delta G. I looked these up and then I used that. I looked up the Kb value in the back in the appendix, and here is I calculated the delta G off of it. All right. Here are my sources, and the thumbnail is this. It's the formula bridge. In order to go from G to delta uh, to K, or delta G to K, you got to use this formula bridge. All right. Thanks, and let me know if I can help.